Hi, BC Calculus students. In this video, we're going to cover the 2019 free response questions. We will only cover the questions that you can expect to see on the 2020 test. So we're only going to look at those kinds of questions. So for number one, we have, and this is the calculator section, so you will need a calculator. For number one, we have fish enter a lake at a rate modeled by the function e of t equals 20 plus 15 sine pi t divided by 6. And we know that fish leave the lake at a rate modeled by the function L, given by L of t is 4 plus 2 to the 0.1 t squared. Both E and L are measured in fish per hour, and t is the number of hours since midnight. For part A, we need to determine how many fish enter the lake over the 5-hour period from t equals 0 to t equals 5 and give our answer to the nearest whole number. So this is just an integral. We're going to do something different and look at every problem first. So this is an integral. B is what is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5 a.m. So average value is one of those ancillary topics that we were going to throw in towards the end of the year. So here we go. Average value is the mean value theorem for integrals. It has the formula 1 over b minus a times the integral from a to b of some derivative, or a rate really. And so over here, we're just going to say that this is a given rate. So if you're given a rate, and we know that if we integrate a rate, that we have then found the total number of whatever from A to B. And if we want to know the average number that we accumulated from point A to point B, or from time A to time B, then we need to do the fundamental theorem of calculus, which is going to be f of b minus f of a. But since we have this 1 over b minus a in the front, that's going to be f of b minus f of a over b minus a. Now, we know this as the average rate of change when we're given a function and we want to find the average rate of change given that function. So if we want to find the average value, it's the same thing, but you have a rate and you're just going backwards. So you need to use average value when you're finding the average number of something and you're given the rate. And that's what happens in part B. We are the prompt for the question tells us that we are given rates instead of an actual function. If we were given the number of fish as E of t and the number of fish leaving the lake is L of t, then we could just do the regular average rate of change thing. But since these are rates, we're using the average value formula. So we're going to put average value. And then for C, we have at what time t is the greatest number of fish in the lake. So if we have two functions where one function is the number of fish that enter the lake and another function is the number of fish that leave the lake, we can probably write a separate function that we can call, we'll say f of t, the total number of fish is probably going to equal the number of fish that enter the lake minus the number of fish that leave the lake. And so if we want to find out where this function's at a maximum, we need to find the maximum of this function. And then for part D, is the rate of change in the number of fish in the lake increasing or decreasing? And we need to explain our reasoning. So remember that the E and the L are rates. So even F is going to be the total rate at which the fish are entering the lake. So is the rate of change increasing or decreasing? So that means that we need to find the derivative of F and substitute in 5. So all we need here is F prime of 5. And so now when we go back and do all these 4 problems, we know how to attack these and what we should do. So for A, if we're looking for the number of fish that entered the lake over a 5-hour period, we are just integrating E from 0 to 5. So we have the integral from 0 to 5 of 20 plus 15 sine pi t, pi t over 6 dt. And from here, the calculator is going to do the rest of the work. So let's see, I would go to first, make sure your calculator is in radians. And then we want to do math, I believe is math 9. So we want to integrate from 0 to 5, and we want that to be 20 plus 15 e to the, that should be 20 plus, not 15 e to anything, it's sine. 15 sine, we'll do alpha y equals, and we would have pi. So in the place of t, we're going to use x. So pi x over 6 dx, and we just press enter, wait for the calculator. So it says round to the nearest whole number. So that's going to be 153 fish. So this equals 153.457, which we would round down to 153. For part B, what is the average number of fish that leave the lake over the 5-hour period? So we said average value is just 1 over b minus a multiplied by whatever the integral of whatever rate. So in this case, we're going to have 1 over 5 minus 0 times the integral from 0 to 5. And the fish leave the lake at the rate of 4 plus 2 to the 0.1 t squared. So 2 to the 0.1 t squared plus 4 dt. So when we're putting this in our calculator, so 1 over 5 is just going to be 0.2. So I'm just going to do, well, we'll have alpha y equals, so 1/5. And then we need the integral from 0 to 5 of 2 to the 0.1. In the place of t, we're going to use x. So x squared plus 4 dx. And we get the average value is 6. So that probably means that we can expect that 30 fish left the lake, about 30 left the lake in the entire from midnight to 5 a.m. So this equals 6.1, but we'll just say 6, which we're going to round down to 6.1. We'll round down to 6. For part C, at what time t is the greatest number of fish in the lake? Now, again, remember that E is a rate and L is a rate. So F is going to be a rate. So if you already have a rate and you want to determine where the greatest number of fish occur, you need to see where the graph of this rate switches from positive to negative. So we're going to just type our function in. So f of t is E minus L. So we're going to go to y equals. It would be great if we could use Desmos for something like this. So 20 plus 15 sine alpha y equals pi x over 6. I don't know why I have double parentheses. I guess it doesn't really matter. And so minus, and then, so don't forget to put this in parentheses, the minus 4 plus 2 to the t squared thing. So 4 plus 2 to the 0.1 x squared and close parentheses. So you're going to graph this. Oh, we'll see what kind of graph you get. It's going to go up. It's going to go down. So when you first get this, the smart thing to do would be to press zoom. Let's still graphing. All right, so zoom, and we're gonna say zoom fit. So we get all of our graph on here. And this is going to take a while because this is just what it does. What is this? All right, so zoom 9. Where is it? Zoom 9. All right, so that'll work. And this is taking forever. And it still doesn't give us the graph that we want. So if we do zoom standard, let's see what we get first so we can maybe adjust our graph. Most of the work is going to be just determining the window that we need. So while this is doing its thing, so we can use some number reasoning to know that sine is going to be between -1 and +1. So this has a maximum of 35 and a minimum of +5. And then if e is going to be from 0 to 5, then t is going to be from 0 to 5. This value of t squared is going to be from 0 to 25, and 25 times 0.1 is 2.5. So you're looking at 4 to the 4 plus 1 is 5, and 2 to the basically third power is 8. So this is going to be somewhere between 5 and 12, and this is going to be somewhere between 35 and 5. So if you're looking at the maximum value of 35, this is going to be a maximum of 35. This is going to be a maximum of 12. So 35 minus 12 is going to be 23. And then this has a minimum value of, so this has a minimum value of 5, and this has a minimum value of 5 as well. So on this interval from 0 to 5, we could look at from 0 to 30. We'll go from 0 to 35 here. So we're going to change our y's to be window, and we'll say from, just to be on the safe side, we'll say 0 to 50. And we can make our scale go by 5s instead. So when we now graph this, we get, oh God, hurry up. So the one thing I should have done is make the window, because we need the value, this value right here where it crosses the x-axis, I should have made my window have the possibility of being negative. So we're going to go back and make that -5. And now we're going to graph this again. It's going to take forever. Ignore these squares or whatever. It's from some stat plot that I haven't turned off, but is not relevant to the problem. So our maximum occurs on the interval from 0 to 8. So it occurs in this interval from 0 to 8. So that's going to be wherever this thing crosses the x-axis. So we just need to calculate the 0, and we get in the range. So the left boundary is going to be here, right boundary, we'll put it here. And we'll say our guess is right there. And the 0 is 6.2. So at 6.2, and your justification is because f of t changes from positive to negative. And again, because f of t is a rate, then that means the function that this rate models changes from increasing to decreasing, which is going to indicate a maximum. And so then for D, is the rate of change in the number of fish in the lake increasing or decreasing at t equals 5. That just means we need to find f prime of 5. And fortunately, we already have this graphed, so we can just use this function. So we're going to go to the run matrix, the main screen. So we have math, and we're going to do the n derivative of x. And we want to do that y1 function. And to get that, we're going to press vars. We're going to go to y vars. We're going to press y1. And then we want to evaluate that at 5. And we press enter, and we get negative 10.7. And so f prime of 5 is equal to negative 10.7, which means that the number of fish in the lake is decreasing. So again, because we knew that f was already a rate, if we want to know if the rate of change is increasing or decreasing, that means that we need to know if the derivative of the rate is positive or negative at that value. You would not substitute 5 in directly to f. You need to do f prime of t. The other way that we could have done this is we could have done math 8, and you could have typed in both of these functions here, where we could have done e, like we could have typed in whatever e was, which was the sine function minus the exponential function, and then put in x equals 5. But since we already had the function in y1, that was easier. For number 2, we so we skipped number 2. Number 2 was a polar coordinates question that won't be on this year's exam. So the rest of this is no calculator. So for number 3, we have a function. The function f is defined on the interval -6 to 5. The figure above shows the graph from -2 to +5. And it consists of 2 line segments, a quarter circle, the 0.53, and is centered at the 0.53. And it is known that 3 minus square root 5 is on the graph. And for A, we need to know the integral from -6 to -2. If we know the integral from -6 to 5 is equal to 7, and we need to show the work that leads to the answer. So the first thing is that the function's continuous. That's going to be important. The function is continuous. And then, so for A, let's talk about how we do A. So we need to know, so like -6 is over here somewhere. So we need to know just what the value of the integral from -2 to -6 is. If we know the entire integral from, we'll just put a -6 out here. So at -6, the graph could do whatever, but we know the integral from -6 all the way over to 5 is 7. So the total area from -6 to +5 is 7. So we're going to use some shorthand. We know the antiderivative from -6 to 5 is equal to the sum of any integrals that we want that fit in this interval. So we could say that that is the integral from -6 to -2 plus the integral from -2 to 5. Now, we know this value because it's given to us, and we know this value because we actually have the graph and we can calculate that ourselves. And so then if we know these two, to find this, we just have to subtract the integral from -2 to 5 from the integral -6 to 5. For B, we can just distribute the integral over the addition and then integrate. For C, is going to be the second fundamental theorem of calculus. And for D, it's that tricky question I told you all about in class, where seemingly you have to do L'Hopital's rule, but the first thing you should always check for finding a limit is just substituting in the value. So for part A, we know that if we had, so since you have to show this formally, we know that the antiderivative from -6 to 5 of f of x dx is the antiderivative from -6 to -2 of f of x dx plus the antiderivative from -2 to +5 of f of x dx. And we know this integral is equal to, it has a value of 7. So 7 is going to equal the antiderivative from -6 to -2 of f of x dx plus whatever the value of this integral I'm about to underline in blue is. So the value of this integral, we can just look at the area under the curve. So from -2 to 5, you have this area and this area. Basically, they cancel out. And so then you have this small amount of area. So you go up 1 over a half. So this is a fourth. So this area is -1/4 because it's below the x-axis. This area is +1/4 because it's above the x-axis. So this area and that area also cancel out. So the only area that we need is the area of this trapezoid piece plus this part. So the area of this trapezoid is, the height is 1. Well, we can just make it a square and a triangle. So the area of this square is 1. The area of this triangle is 1 times 2 times a half. So it has an area of, 1/2 based on height. So 1 times 2 is 2 times a half of 1. Yeah, it's the area of 1. What am I saying? So this trapezoid has an area of 2. And then the area of this figure is, if we look at, so it's a square where we want to know the portion that is not the circle. So the area of the square is 1, 2, 3, 1, 2, 3. So the area of the square is 9. But we need to take out this part of the quarter circle. And the circle has a radius of 1, 2, 3. So the area of the circle is going to be 9 pi. And then a fourth of that is going to be 9 pi over 4. So the total area is 2 plus 9 minus 9 pi over 4, which is 11 minus 9 pi over 4. And so that's what we fill in right here. So we have 11 minus 9 pi over 4. And then if we want to solve for the integral from -6 to -2, then that means we need to move these values to the left, I'm sorry. So that means we're going to subtract 11, which will give us -4, and then we add 9 pi over 4. So -4 plus 9 pi over 4 is equal to the antiderivative of from -6 to -2 of f of x dx. So again, all we did was we found the area of the integral from -2 to 5. We were given the value of the integral from -6 to 5, and we subtract those two values to find the integral from -6 to -2. What makes this complicated is the artificial difficulty of messing around with pi's and finding the areas of weird shapes. For letter B, we may have room to work B right here. We'll take this out. So for B, we need to find the antiderivative. So we need to do the integral from 3 to 5 of 2f prime of x plus 4 dx. And now again, you're given the graph of f above. You're shown the graph of f like right here. So when we integrate this, you can distribute over addition. So you can distribute the integral over addition. So this is going to be the antiderivative from 3 to 5 of 2f prime of x plus the antiderivative from 3, I forgot the dx, plus the antiderivative from 3 to 5 of 4 dx. So when you integrate this, you would get 2f of x, and then you have to apply the fundamental theorem of calculus. And over here, we would get 4x, so plus 4x, also evaluated from 3 to 5. And so that's going to be 2 times f of 5 minus f of 3. And that's going to be plus 4 times 5 minus 3. So that's what, 8. So for this integral, we get 8. We know that f of 3 is 3 minus the square root of 5. Now the question is how we find f of 5 though. So what we want is, so we know we want to find the integral from 3 to 5. So, and that's going to be so f of 5 is 0 if we're looking at the graph. So that's going to be 2 times 0 minus 3 minus the square root of 5. So that's going to be -6 plus 2 square root 5 plus 8. So total, I'm sorry, that's off the page. So total, we get 8 minus 6 is 2. So it's going to be 2 plus 2 square root 5. Now, again, we know f of 5 is 0 just by looking at the graph. F of 3 is this value here. They had to give us that, and that is 3 minus the square root of 5. So the real work was distributing our integral over addition and then just integrating. For part C, we need to find the absolute maximum value of g on the interval -2 to 5. So absolute extrema can occur at endpoints or critical values. So we have a critical value at, so we need to find the absolute maximum value of g on the interval. So then we need to find the critical value for g of x. So g prime of x is just equal to f of x. And that's because of the second fundamental theorem of calculus. The derivative of this integral is just f of x. And our critical values can occur at the endpoints or where we have critical value. I'm sorry, the maximum or minimum can occur where we have our endpoints or at our critical value, which seemingly is a half. So we need to know g of -2. We need to know g of 5 because these are our endpoints. And we also need to know g of 1/2. If we want to find, do we know any of, are we given any of these values immediately? No, we are not. So it's going to make sense then to, so if we want to find g of -2, that's going to equal the integral from -2 to -2 of f of t dt, which equals 0 because you did not go anywhere. G of -5 is going to equal the antiderivative from -2 to -5 of f of t dt, which equals, so we're going from -2 to -5. I'm sorry, +5. I don't know why I wrote -5. So from -2 to +5. So we already know what that is. We did it earlier. It was it 9? It was 11 minus 9 pi over 4. So 11 minus 9 pi over 4. So pi over 4 is less than 1. So this number is a positive. This number is greater than 0. And then we also need g of 1/2. So g of 1/2 is the antiderivative from -2 to +1/2 of f of t dt, which equals, so from -2 to 1/2 is going to give us, this cancels out, we get a 0, and then we get the -1/4. So at 5 is our absolute maximum. And all of this is just using the second fundamental theorem of calculus over and over again. For part D, we have to find the limit when x approaches 1 of all of this. So in the past, there's always been a L'Hopital's rule question, or frequently there's been a L'Hopital's rule question on the AP exam. For this problem, you actually don't need L'Hopital's rule. You can just substitute in 1. If you substitute in 1, because the easiest way to find the limit is to substitute in the value. So that would give us 10 to the first minus 3 times f prime of 1. And we're just going to use this as the fraction bar over f of 1 minus, I'm just going to put tangent inverse instead. So tangent inverse of 1. This equals, so f prime of 1 is the slope of the graph when x is 1. So you go up 2 and over 1. So this is 3 times 2. So 3 times 2 is 6. 10 minus 6 is 4. So we end up with 4 over f of 1 is, so f of 1 is 1 if you look at the graph. So 4 over 1 minus tangent inverse of 1 is pi over 4. So that's your final answer. 4 over 1 minus pi over 4. You don't actually have to do L'Hopital's rule because you don't get 0 over 0. So you can just find the limit. For number 4, I'm pretty sure we did this question in class before, but we'll go back over it. So we have, I'll let you read this, pause it, and come back. So the key parts that you should have picked out, dH over dt is negative 1/10 square root h. We need to find the rate of change of the volume in the barrel with respect to time when the height of the water is 4 feet. You're given the diameter is 2, which is going to be an indicator that r equals 1. So for part A, we can actually work it in this space that we have. So if we're trying to find dv over dt, dv over dt is going to be pi r squared dh over dt plus 2 pi r h dr over dt, product rule. And because it's a cylinder, the dr over dt is going to equal 0 because as the water goes up or down, the radius doesn't change. So this part of the problem actually just cancels out. So we end up with dv over dt is equal to pi times r squared is going to be, so r is 1, so r squared is going to be 1, so pi times 1. And then we need to know dH over dt when the height is 4, which means we can substitute 4 in right here. So the square root of 4 is 2. 2 times negative 1/10 is negative 1/5. So we get negative 1/5. That's going to be negative pi over 5. For B, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? So we need to know if this rate is positive or negative. We need to know if the rate of change of this is positive or negative to answer this question, which means we need the second derivative. So for B, we're going to have d2h over dt squared, just second derivative, is, so this is h to the 1/2 power, right? So when we write our second derivative, you're going to have a half times negative 1/10, which is negative 1 over 20 h to the negative 1/2. And because it's a related rates problem, we need to multiply by dH over dt, which is going to be negative 1 over 20 h to the 1/2. And then dH over dt is negative 1/10. We're going to have h to the positive 1/2 in the numerator. So the h's cancel, and we have negative 1 times negative 1 is 1 over, we end up with 1 over 200. And because this rate is greater than 0 for all values of t, for all values of h, I mean, then this is going to be increasing. So we can put dh over dt is increasing because the second derivative is greater than 0 for all values of h. For part C, at time t equals 0, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So I know, yeah, we for sure did this in class. So when we are doing separation of variables, let's see. Well, I need some room. Do I have? Got plenty of paper. All right, so we have this differential equation where we have dh over dt is equal to negative, I'm just going to do negative square root h. So negative square root h over 10. So a separable differential equation, we want to get the t's on one side and the h's on the other side. So that means we would have dh, I can divide by the square root of h. So dh over, we'll do negative square root h is equal to dt over 10. And we know the initial value is when t is 0, the height is 5. So we'll keep that in mind. T equals 0, h equals 5. So this is, so because these two things are equal, their antiderivatives are equal. So the integral of, so negative, we want to say h to the negative 1/2 dh is equal to the antiderivative of 1 over 10 dt. And the h to the negative 1/2 is because the square root of h is in the denominator. So when we integrate, we get negative h to the positive 1/2 divided by 1/2 is the same as multiplying by 2. And then we get 1/10 t plus some constant. So we know that when t is 0, h is 5. So we would have negative 2 square root 5 equals 1/10 times 0 plus c. So c is negative 2 square root 5. So negative 2 square root 5 equals c. And since we have to write our expression, we would have negative 2 square root h is equal to 1/10 t minus 2 square root 5. And if you had to write this in terms of, so you want h in terms of t, perhaps, so write h in terms of t. So that means that we need to divide both sides by negative 2 and then square. So we would have h is 1/10 t minus 2 square root 5. This quantity divided by negative 2 squared as our final answer. And you don't actually have to simplify this. You could if you wanted to. For number 5, we have consider the family of functions 1 over x squared minus 2x plus k. K is a constant. And we need to find the value of k such that the slope of the line tangent to the graph at x equals 0 equals 6. So for A, we need to find the derivative, set it equal to 6, and substitute in 0 for x, and then solve for k. For B, we need to integrate from 0 to 1 with 8 substituted in. That's going to be a partial fraction thing. And then for C, we need to find the value of this integral or show that it diverges, which is an improper integral question, probably. Improper integral. This is probably going to be a partial fraction. And this one's just a derivative. So for 5a, we have, all right, we can rewrite this as x squared minus 2x plus k to the negative 1 power, right? So for 5a, f prime of x is equal to negative 1 times x squared minus 2x plus k to the negative 2 power. And then because of the chain rule, we multiply by the derivative of the inside. That's going to be 2x minus 2. And we can rewrite this with positive exponents, so we get negative. So we're going to distribute this negative 1 over to the 2x minus 2. That's going to give us negative 2x plus 2 over x squared minus 2x plus k squared. And we know that when x is 0, the slope of the tangent line equals 6. So when x is 0, the derivative is 6. So that's going to imply that at x equals 0, we get 6 equals, so if x is 0, in the numerator, all you have is 2 over, if x is 0, you're going to have 0 minus 0 plus k, so over k squared. And if you're solving for k, then you would have you would have k squared is equal to 2 over 6. And they tell us that k is positive. So that means that k squared equals 1/3. And so k equals plus or minus the square root of 1 over the square root of 3. And so we drop the negative because k is greater than 0. So we don't need the negative. So for a, k equals the square root of 1/3, which is 1 over the square root of 3, which if you want to keep simplifying is the square root of 3 divided by 3. For b, we're finding the value of this integral from 0 to 1 if k is negative 8. So for 5b, we are integrating from 0 to 1 of 1 over x squared minus 2x minus 8. We want to put a dx in here, so we'll say 1 over that dx. So this is a partial fraction question. So you can rewrite this integral to be the integral from 0 to 1 over dx over x minus 4 times x plus 2. The function is continuous and integrable on the interval 0 to 1 because our zeros are at 4 and negative 2. So remember, for partial fractions, we said that you could get some real estate here. So this integral is equal to the integral from 0 to 1 of some number over x minus 4 plus some other number over x plus 2 dx. And we did the shortcut way of finding a and b. To find a, you cover up the term that a is over and substitute in that 0. So if we cover up x minus 4 and substitute in 4, we're going to have 1 over 4 plus 2 is 6. So we get a equals 1/6. Because again, you cover up the x minus 4 and then you substitute in 4 because that makes this equal 0. So 1 over 4 plus 2 is 6. So we get 1/6. And similarly, to solve for b, we get, you cover up the x plus 2 and substitute in negative 2, you get b equals negative 1/6. So what we are actually integrating is the integral from 0 to 1 of 1/6 over x minus 4 minus 1/6 over x plus 2. Both of these are very simple. You could do U substitution. It's not actually necessary. You would get 1/6 ln absolute value x minus 4 minus 1/6 absolute value x plus 2, and you're evaluating from 0 to 1. And so when you substitute in 1, you're going to get 1/6 ln 3 minus 1/6 ln 3. No, I don't know where I put absolute value. And then minus, when you substitute in 0, you're going to have 1/6 ln negative. So it's going to be ln negative 4, but in absolute value is going to be positive 4. So 1/6 ln 4 minus 1/6 ln 2. And since these cancel, your final answer is 1/6 ln 2 minus 1/6 ln 4, because we distribute our negatives and so forth. Yeah, that's it. I mean, you could actually say this is 1/6 ln of a half if you wanted to, because 2 over 4 is going to reduce to be a half, but you could stop here. So for C, do we have room? We'll find out. So for part C, we need to integrate from 0 to 2 or show that this diverges. So when K is 1. So if K is 1, we have the integral from 0 to 2 of 1 over x squared minus 2x plus 1, which is the same as the integral from 0 to 2 of, so x squared minus 2x plus 1 is x minus 1 squared. So this is x minus 1 to the negative 2. Because again, this, did I run out of room? We'll put this over here. This is x minus 1 squared. And since it's in the denominator, we move it up and make the exponent negative. And so we have x minus 1 to the negative 2. And when we integrate that, we would get, so we have an improper integral situation where our value at 1 is going to make this blow up because the function is not continuous at x equals 1. So we have to split our integral into 2 pieces. So for 5C, we have one integral is from 0 to 1 of x minus 1 to the negative 2 dx. Then we have plus another integral from 1 to 2 of x minus 1 to the negative 2 dx. Now, either way, this we have the same integral. They're going to integrate to be the same thing. So when we integrate, we have x minus 1 to the negative 1 over 1. And we're evaluating that from 0 to 1. More on that in a moment. And then plus, divided by negative 1. So x minus 1 to the negative 1 over negative 1, evaluated from 1 to 2. So the problem is when you substitute in 1, you're going to divide by 0. So we end up with negative 1 over x minus 1, evaluated from 0 to 1, plus negative 1 over x minus 1, evaluated from 1 to 2. And the reason we said that this is an improper integral is that when you integrate this, because the ones give us 0 in our denominator, we actually need to calculate a limit. So if we did, so we're going to say the limit as b approaches. So if we're going from 0 to 1, we're approaching 1 from the left. So we're approaching 1 from the left of negative 1 over x minus 1 from 0 to b. When x is really close to 1, this is going to be a very, very small negative value. And negative 1 divided by the x minus 1. So imagine x is like 0.999999. I'm sorry, if x is really close to, so 0.99999. So you're going to have like 0.000001 divided into negative 1. This is going to go out to negative infinity. a positive infinity, because it's going to be a very small negative value divided into negative. And this is going to be divergent, because when you get very close to 1, then this value is effectively 0, a very small number divided into -1. And a similar thing for 1 on this side. If you approach 1 from the right, if you have like 1.00000000001, so if you had 1 over this difference, then this is going to be a gigantic number. And so this is also going to be divergent. So the answer is divergent. I'm trying to beat this thing because I think my phone is going to die. And so we have a lot to do for 6, but actually we don't, because the only thing that's testable that we know how to do is A. So we have to write a 3rd degree Taylor polynomial for x equals 0. So that means that we need to know f of 0, we need to know f prime of 0, we need to know f double prime of 0, and the 3rd derivative at 0. So they give us the 2nd and 3rd derivative at 0 is 3 and -23/2. F of 0 is 3, because we can see that by looking at the graph. So f of 0 equals 3. And then f prime of 0 is the slope of this line, which is, you go down 2 and over 1. So f prime of 0 is -2. And so a Maclaurin polynomial, because it's at 0, is going to be f of, I'm going to start over. It's going to be f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 factorial plus the 3rd derivative at 0 times x cubed over 3 factorial. So f of 0 is 3 plus f prime of 0 we said was -2. So -2 times x. So we could just write -2 instead. F double prime of 0 is 3. So plus 3x squared over 2 factorial, which is 2. And then the 3rd derivative is -23/2. So minus 23x cubed over 2 times 3 factorial is going to be 12. So we're going to have P3 of x is equal to that. So again, for a Taylor polynomial, you need, for whatever degree, you need that many derivatives. So we had the original function, the derivative, the 2nd derivative, and the 3rd derivative. All right, guys, that concludes a rather lengthy video. I apologize for the calculator problems at the beginning. I hope you all are doing well, and there will be another video tomorrow that goes over another AP exam. Stay safe.